Hi everybody, in this video we are doing the next three examples in a set of practice type of problems, solving 30, 60, 90 triangles and 45, 45, 90 triangles. These examples are to prepare us for the unit circle, which is a way of understanding the proportions of the sides of 30, 60, 90, 45, 45, 90 triangles that exist in the unit circle and how those proportions relate back to the angle and vice versa, yada, yada. So it's a big underlying theme in trigonometry. So let's go ahead and get started. So first one we're going to look at is example number 4 over here, right? Now in example 4, I have one of the sides of a 30, 60, 90 triangle given to me. We know that this angle needs to be 30 because, make this a little thinner, 30 because I know that the three angles, that's 180, 90 is the corner right over here, and the other two then must share 90 in total. 60 subtracted from 90 left me with 30. Boom, done. Now this side is what we call being across or opposite from the 30. That will be the shortest leg. So I'm going to call that side S for short leg. The relationship based on the rules that we talked about already is that the longer leg is equal to the short leg times the square root of 3. And then the hypotenuse, which is this side here, is equal to 2 times the short leg. So it's pretty nice when you're given the short leg right away. So in order to use that, right, all we're going to have to do is, oh, I wanted to make sure I used the same colors and now I don't remember what I did. I think I used green for the short leg before. One second, let's look at the I just want to double check. Ah! Yes, green for short and okay, pink for that. Okay, so green right here. This is my short leg, and I know that the length of it is 6, and I used S to stand in for it, right? Now that S is going to get plugged into that little formula there and that little formula right there, right? And then my long leg is S times root 3, and that's this guy right here. So let's dive right into that one, shall we? So all I need to do is L equals 6 root 3. And then I look at it and ask myself, is there anything that I can or should simplify? And after you think about it, you should realize, no, there's nothing you need to do. It's as simplified as it can get. We are good to go. Next, we're going to look at the hypotenuse and the hypotenuse rule right over here. So right underneath, I will address that. H equals 2 times 6. Now I ask myself, is there anything I can do to simplify this? Well, I could really just finish the problem, right? 2 times 6 is 12, so H is 12. And there you have it. That's the end of number 4. Let's look at number 5. Number 5, right over here, we are looking at a 45, 45, 90 triangle. And in here, I can use yellow, I believe, for the hypotenuse, and the legs are both the same. It's an isosceles right triangle. Isosceles has at least 2 sides the same. So really, an equilateral or equiangular triangle is also an isosceles. But that's neither here nor there at the moment. So that right there has to be 45 as well. There's your 45. The rule, we usually use the leg. Since both legs are the same, I'm going to use L. L, and this one is L. Well, let's even write it as H equals L times the square root of 2. So just like that last one, if I know one thing, I could really just sub it in and solve for the other. So this right here is H. So I know H equals 2 root 2. So if I go ahead and fill that in, I will have 2 root 2 which is h equals L root 2. Divide both sides by root 2. Reduce. And what does that leave us with? That leaves us with L, which I'll rewrite it on the left because it makes it a little nicer for us. L equals 2. Is there anything we could clean up? Not so much. So L is 2, so that really found us our 2 missing sides. So done with that and that. And that right there was that. All right, last one over here, number 6. So again, hopefully I do the right thing. Green was the short leg, pink is the long leg, and that's the one I'm given, and yellow for the hypotenuse, right? Now, the formula or the rule that we know really bases it off of the short leg being given, but that's okay. S is equal to this side right here, short leg, but then this side, long leg, equals S root 3, and hypotenuse is equal to 2 times S. So what am I going to do? I'm going to figure out what S equals by basically using this right over here. So that long leg I know. That one is the pink side. That's L. I'm going to fill that in right there. And then I'll solve for S. Once I know what S is, not only do I have the short side, but I could also figure out the hypotenuse by filling in the S. So you kind of see how one thing leads to the next, right? So let's go ahead and get this done. So 4 root 3, these beginning examples are very sweet. 4 root 3 equals S root 3. Divide both sides by root 3. When I do that, maybe I shouldn't write it like that. I guess it's not the best. So I'll be more proper so nobody picks up any weird habits. So S equals 4. So what did I find? I just found the length of the shorter side. So S is equal to 4. Now we're going to fill that in to find H. H equals 2 times 4. So H equals 8. So right there, H is equal to 8. I'm going to label that right underneath. H is 8. And there you have it. All done. So those are the next 3 examples in this little list of this worksheet of practice problems. Hopefully you found that helpful. If so, if you got them right, give Bear over here a thumbs up. If not, thumbs down. What do you need? Faster, slower, more explanation, more work, less work? You tell me. Check the playlist on the screen for unit on pre-trigonometry, everything you need to know before you begin trigonometry if you want to be a superstar. That's it for now. Adios.